Hi, now we're going to get a feel for how to develop an application using the Antares protocol. Antares is all about assigning consequences to events, which we've defined earlier. We have a node program that writes a list of names to a file, but we're going to refactor it until we've clearly separated the events, what we want to happen, from their consequences, effects that actually happened. Here's our setup. In this pane, we have the source code of a program that's going to run and append each name to a list. We also have the file open that contains the list of names, and we also have in the terminal window a nodemon script that will clear and repopulate the actor's YAML file anytime we change something. So, for example, if we were to make this that, it would live reload. All right, our goal will be to improve the flexibility of the program by decoupling it, keeping an eye on separating what happens, what is to happen from how it happens, and we'll also change its operation and timing by only controlling a few parameters with minimal rewriting. So first, let's get to the business of separating the what from the how. Our preferred way of defining what is to be done is going to be with an object called a flux standard action. And we're going to imagine now that we have a helpful agent to whom we're going to hand off an action of type add to list. This is a flux standard action. And the payload will be the name given. And how we're going to fill that in a second. So we're crashing because agent is not defined. That is easy to remedy by requiring a constructor from the Antares protocol library and just creating an instance of it. At this point, we have created the agent and told it to process one of each of these names. But what we haven't done is exactly define how we're going to do that. So let's do the following. Let's create a function and call it a list writer who's going to take an action. But in this case, we're actually going to take an action from a subfield of an object. And then if only we were to take the name off of the payload, we would then be able to write it. So now we've written a function, but nothing's happening in our file yet because we have not told Antares when to do this writing. And so we're going to do that right here. We're just going to say agent.on add to list, give it to the list writer. And now magically we have fixed the problem. Now we have a part of the program whose only job is to create these specifications of what is to be done. You're to add a name to a list, and then Antares makes it so that when you call process, any applicable actions are run. So that's pretty cool. Antares has a very small API, and on is one of them, process is one of them. The other big one is called add filter, and it's one that we can use to see down here in the terminal pane the names that we're about to process. So let's just go ahead and say add a filter that will log the action's type and the name and the payload, and that will run prior to every action. And also, let's take advantage of this separation that we have between the what and the how to say that let's make this proper YAML as well and append that little hyphen so that we have a valid YAML file, all without changing the part of the program that speaks to what is supposed to happen. All right. All is well. We like this program, but a new requirement comes in. And we need to put the name on a remote message queue as well. But let's actually not do that. Instead, let's simulate a long-running process that does something a little more fun. It's gonna say the name aloud. So let's define a function. Just like the list writer, let's define another function with the same signature that pulls in the say library, takes the name from the payload, and calls say.speak with I like the name. And say.speak takes the text to speak, a couple of parameters controlling the voice and speed, which we'll ignore, and then a callback to call when it's done speaking, which we'll use in just a second. Now, how would we tell Antares that in addition to calling the list writer, we want to say the name aloud? We are going to set up the agent a little bit more by just saying agent.on add to list. Well, then say it aloud. There it is. All right. And now,
I like Mark.
Could you hear that? That was, let's take jQuery out of this list. That was a Scott Hanselman joke gone bad.
I like Mark.
All right. So all is well, but not. Our filter is showing us the name of each action we're about to process. The file writer is getting the names. Our next challenge is going to be to make these spoken renderings not overlap. So it's almost as easy as saying the following. For our say it aloud renderer, we want to run in serial mode.
I like Mark.
But it's not quite there yet. You heard them still overlapping. And that's because you don't have a way right now to communicate exactly when that say.speak is done. It has a callback, but we weren't doing anything with it. So we're going to use another constructor from another library, observable, from the RxJS library. And then we're simply going to do the following. If you're familiar with promise wrapping, this is going to look a little bit similar. So first, we wrap the action we want done in a notify callback for this promise-like thing called observable. And then we call notify.complete in the callback.
I like ScarJo. I like Chris Hemsworth. I like Mark Ruffalo.
And now we see the true power of really configuring our how part of the program completely independently of the above. And we can change the behavior, of course, by simply toggling modes, which is very, very powerful. All right. So we've almost taken it as far as we can, except it's good to know when a rendering is done. Okay, so we kind of want our log to look not just like this with add to list, but we want to see actions of speak done that are going to come up each time our speaking completes. So that's what we're going for. And in order to do that, we're going to take advantage of the fact that an observable is not just usable to control the timing, but it can be used to send out notifications. So for example, we can notify with an action of type speak done and a payload containing the same name.
I like ScarJo. I like Chris Hemsworth. I like Mark Ruffalo.
Yeah, and so now we are kind of alerting that we're done, but we still have to tell Antares that this output on the observable is worth listening to. And so we'll just do that right here. We'll say
I like ScarJo. I like Chris Hemsworth. I like Mark Ruffalo.
We want to treat the actions that it emits as part of the Antares action stream. So, in summary, we learned that we can separate our program into a what section and a how section. In a real application, events from the user or from the outside world become actions that we send through agent.process. And then changes to the DOM or writes to the network or a database or API or any other consequence we want are implemented in the how section by renderers. And we attach renderers to the agent via the on or the add filter method. And then each renderer is like a little microservice in charge of its own domain. So I hope you can see that this lets us use a few core concepts to put together a program that is infinitely flexible. And I think most importantly, we're not starting inside of a user interface framework like React or Angular. and we're not starting off bound to a database, but as you see later, we can add those. And that is how we build an application using an instance of an Antares agent.